Have you ever wondered why water is wet? Is that even a sensible question? Well, it's understandable if you've never given it much thought. After all, water's wetness is something we take for granted, isn't it? But if we pause to ponder, we realize it's not as simple as it seems. What do we even mean when we say something is wet? Interestingly, wetness isn't a property of water alone. It's our perception of what happens when we come into contact with it. A sensory experience that's a result of various scientific phenomena at play. So when we're talking about water's wetness, we're actually delving into the world of physics, chemistry, and even biology. But why does this matter? Why should we care about water's wetness? Well, water is not just a thirst quencher or a means to clean. It's a life sustainer, the backbone of our planet's ecosystems, and the reason we exist. Understanding the unique properties of water, including its wetness, can help us appreciate its role in our world better. And that's what we're going to do today. We're going on a journey, a deep dive into the science behind water's wetness. We'll unravel the unique properties that make water the way it is, and we'll see how these characteristics impact life on Earth. We'll also pepper our journey with some fun facts about water, because who doesn't love a good trivia? Did you know, for instance, that water is the only substance that occurs naturally on Earth in three forms: solid, liquid, and gas? There's so much to discover, so much to learn, and it all starts with a simple, seemingly nonsensical question. Why is water wet? So buckle up as we dive into the world of water and its fascinating wetness. First off, let's tackle this. What does wetness even mean? Well, it's a bit of a head-scratcher, isn't it? But let's break it down. In scientific terms, wetness is not a property that a substance like water inherently possesses. Instead, it's a sensation, a result of the intricate interplay between our tactile senses and the physical properties of the material we're touching. Imagine, if you will, holding a smooth pebble in your hand. It's cool, hard, and has a certain weight to it. These are all properties that the pebble possesses. Now dip that pebble in a pool of water. When you touch it again, it feels wet. But what's changed? The pebble is still the pebble, and the water is still the water. It's your perception that has altered. This is where the magic happens. When we touch water, or any liquid for that matter, our skin interacts with it. The liquid spreads across our skin, reducing friction and enhancing thermal conductivity. This triggers nerve endings in our skin to send a message to our brain, which interprets this as wetness. It's an amazing conversation between our bodies and the world around us. You might be thinking, well, that's all very well, but why does water feel wetter than other liquids? That's down to water's unique properties. Water molecules are extremely good at sticking to surfaces and to each other. This is due to their polarity, which allows them to form bonds with other molecules. When you dip your hand in water, these molecules cling to your skin, spreading out to cover as much surface area as possible. That's why water feels so thoroughly wet. This might seem like a simple, everyday experience, but it's actually a complex dance of physics and biology. It's a testament to the intricate ways in which we interact with our environment. So, wetness is not just about water. It's about how we perceive the world around us. It's about the beautiful complexity of our senses and the incredible adaptability of water. Now, let's explore what makes water so special. First off, we have surface tension. This is the elastic tendency of liquids which makes them acquire the least surface area possible. Think of it as a sort of skin that allows small insects like water striders to walk on water without sinking. It's all thanks to the cohesive forces between water molecules that create this tension and make it possible for water to resist external forces. Next up, we have adhesion and cohesion. These are two fantastic properties of water that contribute to its wetness. Adhesion is the tendency of water molecules to be attracted to other substances. It's why water spreads out when spilled on a table or why droplets stick to the sides of a glass. Cohesion, on the other hand, is the tendency of water molecules to stick to each other, forming droplets or allowing water to flow in a continuous stream. Now, imagine you're a tiny water droplet. When you come into contact with a surface due to adhesion, you spread out and wet the surface. And because of cohesion, you maintain a bond with your fellow water molecules, creating a film of water. This combination of adhesion and cohesion results in capillary action, where water can work against gravity and move upwards in narrow spaces, like in the stems of plants. These properties of water, though they may seem simple, are incredibly significant. They influence everything from how plants get water from their roots to the leaves, to how ink spreads on paper, and even how blood travels in our veins. Let's not forget the high specific heat capacity of water, which refers to the amount of heat needed to raise the temperature of water. This property makes our oceans a massive heat reservoir, stabilizing our planet's climate. These properties not only make water wet, but also make it essential for life as we know it. Remember, water is not just a simple liquid. It's a marvelous substance with unique properties that play a crucial role in our world. So the next time you take a sip of water, remember, you're not just quenching your thirst, you're experiencing science in action. Water's wetness is not just a fun fact. It has profound impacts on our world. Let's dive into how this seemingly simple characteristic of water affects our day-to-day life and the Earth's ecosystems. Think about your morning routine. The refreshing splash of water on your face, the steam from your hot shower, the ice in your smoothie. All of these experiences are made possible because of water's unique properties. Its ability to exist in 3 different states, as a liquid, solid, and gas, allows us to use it in a multitude of ways. Water's wetness makes it an excellent conductor of heat, so you can boil your eggs and also freeze them. Although I wouldn't recommend the latter for breakfast. But it's not just about us humans. Water's wetness plays a crucial role in the survival of numerous species on Earth. Consider the polar bear, an animal that thrives in icy conditions. Polar bears rely on sea ice for hunting and breeding. The very existence of this ice is a result of water's ability to freeze, a property tied to its wetness. And let's not forget about plants. Water's ability to stick to itself, a property called cohesion, and its tendency to stick to other substances known as adhesion, enable it to travel from the soil up into the roots, stems, and leaves of plants. This process, known as capillary action, is vital for their survival. Even the weather patterns we see are influenced by water's wetness. The water cycle, a continuous process where water evaporates, forms clouds, and comes back down as precipitation, is intrinsically linked to water's properties. So, water's wetness is not just a curious property that makes our hands feel cool when we dip them into a pool. It's a fundamental aspect of water that influences our daily life, the survival of various species, and even the weather we experience. From our daily chores to the survival of polar bears, water's wetness indeed touches every corner of life. So, next time you drink a glass of water or take a shower, take a moment to appreciate the magic of water's wetness. Let's sprinkle in some fun facts about water that you might not know. First off, did you know that water expands when it freezes? That's right. Unlike most substances which contract when they cool, water is a bit of a rebel. When it turns into ice, it actually occupies about 9% more volume than it did as a liquid. This is why ice floats in water. Next, hot water can freeze faster than cold water in certain conditions. This phenomenon is known as the Mpemba effect, named after a Tanzanian student who observed this in the 1960s. Scientists are still trying to fully understand why this happens, but it's a fascinating quirk of our everyday liquid. Also, you've probably heard that the human body is made up of a large percentage of water. But did you know that by the time you feel thirsty, your body has lost over 1% of its total water amount? So remember to sip on that H2O before you feel parched. And here's a mind-boggler. A single water molecule stays in Earth's atmosphere for about 10 days. However, the same molecule can remain in our oceans for over 3,000 years before evaporating or being taken up by an organism. Lastly, have you ever considered how much water is actually on Earth? If all the Earth's water was put into a sphere, it would have a diameter of about 860 miles. That's roughly the distance from Salt Lake City to Los Angeles. But here's the clincher. Despite its abundance, only about 2.5% of Earth's water is fresh, and less than 1% of that is accessible to us. Makes you appreciate every drop, doesn't it? Water, it seems, is full of surprises. If you're enjoying this wet adventure and want to learn more amazing facts, subscribe to our channel. By doing so, you'll join a curious community of individuals just like you, eager to plunge into the fascinating world of science, one droplet at a time. But the interaction doesn't stop there, oh no. We encourage you to dive into our comment section, share your thoughts, ask questions, or perhaps suggest a topic you'd like us to cover in a future video. Your input is valuable in shaping our content, and we love hearing from you. Remember, science is not just about facts and figures, it's about exploration, discovery, and the joy of learning. So why not embark on this journey of knowledge with us? Subscribe, share, and join the conversation. Don't miss out on any drop of knowledge. Let's round off our journey by summarizing what we've learned about water and its wetness. We embarked on this journey with a curious question: why is water wet? A seemingly simple query led us into an exploration of the less traversed territories of science. We discovered that the sensation of wetness is not just about water. It's about how our senses interpret the interaction between water and our skin. We delved into the unique properties of water: surface tension, adhesion, and cohesion. We learned that these properties contribute to the sensation of wetness. Surface tension allows water to spread across our skin, while adhesion and cohesion enable it to stick and form droplets. These characteristics, combined with the temperature of water, generate the sensation we perceive as wetness. We also looked at the broader implications of water's wetness. From the way it influences our daily lives to its role in maintaining Earth's ecosystems, we realized that the wetness of water is integral to life as we know it. It facilitates the survival of various species, governs weather patterns, and even plays a crucial role in our own survival. We peppered our journey with some fun facts about water, adding a dash of humor and surprise to our exploration. Who knew that hot water would freeze faster than cold water, a phenomenon known as the Mpemba effect, or that a jellyfish and cucumber are both 95% water? As we navigated through the science of water, we learned that understanding the seemingly ordinary can lead us to extraordinary discoveries. As we wrap up, keep pondering about everyday phenomena and their scientific explanations. Who knows, you might just stumble upon the next big question. So keep those questions coming, and remember, every drop of knowledge counts.